One consideration. I have Wolverine class.
Who would do?
Make it comedy. Everything good.
Yeah, so let me, if you go to the file upload script on the class web page, it's quite a lot nicer than looking at it through links, as you, I don't know, maybe have already figured out. And one of the nice things about doing it through a browser is you get to choose the file dialog instead of having to type it. And then you can go and sort of pick a file, and then that'll appear right here, and then you put your user ID in here and you click submit and it uploads it, and the possibility for typo does not exist. If you can browse to the file and select it, you're guaranteed to not have a typo. Ben and a couple other people noticed that if you're in there and you're using links and you're trying to upload and you mistype the file name, you'll briefly get this error message, and then it'll sit there for like 2 seconds, and it'll go to a success screen. And for the life of me, I can't figure out how to trap that error in my script. I've looked at different CGI scripting sites and things like that, and I can't figure out how to trap that error, and so I'm just stuck with it right now. And it's partly because uploading files with a text-based browser is not a really common thing to do, and so it just seems like it's an issue that hasn't come up with people, right? Because that's not an issue that's even possible to have in this context, a regular old browser and a regular old upload CGI script. Jamie?
Does it actually upload a file?
Yes.
It just uploads like a 0-byte file.
Oh, okay. It's really weird too. So if you do a typo, it will create the file with the name, with that typoed name in there, and inside the file will be the name of the file.
So it's not even a 0-byte file. So you couldn't.
Right. It's really bizarre.
Is there any way you can access the number of files in the upload directory?
So you have
but it adds 7 bytes. Yeah,
I will admit to have not having tried super hard. I looked at it for maybe an hour, and then I was like, oh, forget it. I'm just going to tell them to be careful. Okay, alternative.
Totally do it.
I'm not setting up a PHP server on my box. Okay, yeah. So, okay. I want one, but not that bad. Okay, another alternative, and in fact, this is something that you might really consider doing, since all of your files are currently residing on a computer in the math lab, actually a computer in my office, but that's another story. There's a free file transfer protocol that will use SSH to transfer files to and from your computer. It's called FileZilla, and there are several different secure FTP applications out there that are free. I chose this one because, in fact, it runs on both Mac and Windows. It's actually not the one that I generally use, but that said, let me show you how it works.
What's the problem with just doing Dropbox?
Dropbox, there was just too much variation in the kind of stuff that I was getting. With Dropbox, what happened is each of you would share a folder with me, and then you would create inside that folder your homework directory. And some people did H2, some people did H02, some people did capital H02, some people did lower H2, and it really wreaked havoc on my scripts, that I use to process and grade and all that sort of stuff, because I have all these little scripts that help me do things. And so if you upload files through my file uploader thing, then I have very tight control about where those files land. Okay, so FileZilla, you can download it for free, and you get to the top here and you can go math.whitman.edu. You can punch in your username, your password, and the port number 22. Make sure you do that because that's a signal to use secure FTP instead of regular FTP. And then what? Just hit enter maybe. Yeah. And on the right-hand side window, what you get are a list of all the files on math. And you can go into 270 and homework 1 and maybe grab, you can actually grab a whole directory if you'd like. So you can grab this directory, drag it over here, and maybe drop it on the desktop and wait a little while. And there it is. Now I can go and start uploading stuff. Grr. This happened to me earlier. There. Windows 8. Still not quite there yet.
Quality operating.
Absolutely. So then I can pick files like complex.cpp. I can just click on it, and now it's there. I can't even misspell it if I want to. And type shula and linked list or whatever or something else, and then click submit. And that is an actual honest-to-goodness success message, not a fake one. So what's the advantage of doing it this way? Now you have copies of your files in 2 different locations, and that's always a good thing. So FileZilla works in Windows and in OS 10. Other questions? So if you've turned in your linked list class and you haven't heard back from me, it's probably there. It's just that I haven't had a chance to grade since Tuesday, really. Today, we are going to talk about evaluating arithmetic expressions. And we're going to start with, how many of you guys have ever heard of reverse Polish notation? A couple people. This is not a joke, okay? Reverse Polish notation. In fact, let me show you. I was going to bring it with me and I just forgot. It's in my office. This is the calculator that I use. Hewlett-Packard 11C. I got it when I was in 8th grade. I shudder to tell you how old this calculator is. I was in 8th grade in 1980. So the calculator in my backpack has been with me for 33 years, 32 years. And I can't use a regular calculator. This is a reverse Polish notation calculator. Reverse Polish notation is another word for what we call postfix notation, where you kind of take things for granted when you use 99% of the mathematics software out there. If I'm using Maple or I'm using a TI-85, almost any website that takes in mathematical expressions, you do things like this: 2 plus 3, maybe use some parentheses, minus 5 times 4 plus 1, or what have you, right? I mean, this is how we generally write expressions in on a TI-85 or a Maple. This is called infix notation. And who would believe that there are actually different ways of writing out these mathematical or arithmetic expressions? But there are. Infix means that the operator occurs between the things that it's acting on. So the operator is between the operands. So the plus sign is between the two things that it's adding, 2 and 3. The minus sign is between the two things that it's adding, this expression on the left and this expression on the right. RPN, or postfix notation, the operator is after the pair of operands. So let me see if I can do this in RPN. So I'll try to redo this same expression. I'll put a comma between the numbers just so that you know that this is 2 and 3 and not 23. I'll put a comma between everything. So 2, 3, comma, plus. Five, 4, 1, plus, times, minus. I think that's it. 2, 3 plus 5, 4, 1, 5, 4, 1 plus star minus. I think that'll work. Okay, that's, I think, is the postfix expression. Let me just double check here. How does this work? Work from left to right. Take these two guys, or take this whole thing and replace it by its result. What's its result? 5. Okay, go to the next operator. Let's see, 4, 1 plus. So that's 5, comma, 5, comma, is that another 5? Yep, comma, minus, like that. And then go to the next operator. And then the last guy. 5 minus 25, is that right? Weird, but systematic. You could imagine that it would be fairly easy to teach a computer to do this, the postfix evaluation, right? And perhaps a little more difficult to do the infix evaluation. So what we're going to do is actually an algorithm that takes infix to postfix and then postfix to the result. So we're going to look at what's called an infix to postfix conversion. And in case you're wondering, yes, there is a prefix notation. I've never seen it used anywhere, but it does exist, and that's where the operator occurs first, and then the two tokens, the two operands.
Is this how the stuff we do it?
Behind the scenes, yes.
Yes.
Behind the scenes, any infix parser is behind the scenes doing postfix conversion and then postfix evaluation. Postfix is just really very methodical. All right, let me show you how I found an RPN calculator app. Thought I found one. That's the one. Thank you. So here's how you use an online an RPN calculator. Let's say I want to add 2 and 3. I do 2, enter, 3, and then I hit the plus sign here, and I get 5. I can do that earlier expression here. So I do 2 plus 3, I just did that one. And now I want to subtract 5 times 4 plus 1. So I do 4, enter, 1, enter. I shouldn't have done that. Let me pop that back. Grr. I don't know how to pop on this. Let me just try plus. Yeah. Okay, so 5 and then 4, enter, 1 plus, and then 5 star, and then subtract. So let me do that one more time. Clear this guy out. This is not my trusty HP, so I'm not as sort of comfortable on this thing. 2, enter, 3, plus, and then I have to kind of do the parentheses in my head. 4, enter, 1, plus, 5 times, subtract. All right. So whenever I'm using my calculator, I'm constantly doing this infix to postfix translation, and it requires me to look ahead for parenthetical groupings and so forth that have to occur before other things. So it's just a habit that I've developed. I had never really even thought about what I was doing, because I'd been using this calculator since I was in 8th grade. I'd never really thought about the fact that in my head I was constantly doing this infix to postfix conversion, at least when I was trying to evaluate an infix expression. It wasn't until I actually learned about stacks and data structures that I realized what the process was for evaluating these things. And so let's look at that. Oh, let me show you one more thing before we look at that. I wrote down the link here. And let me just search for this guy's name. I think that's it. Okay, good. I accept the risk and want to run this app. And if it fails, you can murder my firstborn.
No, she was .edu. This is pretty.
Yeah, it's sketchy. Okay, so here is a postfix expression. 47.4% 2 6 plus minus 3 star, and you're going to watch essentially a stack-based implementation of evaluating this expression. So let's watch it.
The fade.
47 divided by 4 is
Percent. It's a remainder.
Thanks. Okay. All clear. Wow, that was good.
Man, that fade is painfully slow. I'm not complaining though.
So is it just, like, intuitively, I would think that the top stacked element would go in front of the operator, and then the next stack would go to the right, but it doesn't work that way. Is that just my convention?
I'm not sure what you're talking about, Evan. Can you say that again?
So, like, 47.4%,
Yes.
right? 47 gets put on the stack,
Yep.
then 4 gets put
Yep.
on the stack, then you get the operator.
Yep.
I would think 4 would be on the left and 47 would be on the right, but that's just not how it works.
That's not how.
Okay.
Okay. I mean, you can think of it as 47% 4, and you take the percent and you move it post. All right, so there's a postfix expression generator, whatever you want to call it, animation. Let's talk a little bit about how we're going to convert from infix to postfix. And here we're going to use two stacks. And what I'm following essentially the notes from David's book. And this is really painful to try to write. So what we're going to do is I'm going to kind of just describe it loosely in words, and then I'm going to flip over to David's book, and he has a diagram in there that we'll discuss. So infix to postfix conversion. You work from left to right. Infix expression. So you're working from left to right across an infix expression. Let's forget about parentheses for now. Let's just talk about numbers and addition, subtraction, multiplication, and division. So if for a number, you push it onto the stack. Operator, you look at the top operator. So you're in the middle of an ongoing process here. You've been pushing numbers, you've been pushing operators. There are two stacks. So we look at the top of the op stack, and I'll call this the num stack, and the op stack. So you look at the top of the op stack, and you ask yourself, is the operator that I have in my hand a higher priority or lower priority, or sorry, a higher precedence or a lower precedence than the one that's at the top of the stack? So you look at the top of the op stack and you compare precedence. A higher precedence operator, for example, multiplication is higher precedence than addition. So in the grand scheme of things, if I have the addition operator already on the stack and the multiplication operator in my hand, which one of these things has to happen first? Multiplication. So I'm going to push that onto the stack. If it's higher than the top op, then push it onto the stack and move on. If it's lower,
and push
onto the op stack. Yep. And these are all just words at the moment. It really will become clear when we look at a diagram. If lower, then the thing that I'm holding in my hand happens before or after the top op? After. So that means I have to execute the top op before I can push the one in my hand onto the stack. I have to execute the top op and then look at the next one and see if it's higher or lower precedence. In fact, what I have to do, if lower, I have to execute ops until what? Until I reach a lower precedence. Yeah. So I have to execute ops until I reach an equal or lower precedence op, and then push.
When you say execute, at this point we're just doing the conversion.
Well,
So-
think about what it means to execute. Let's talk about how you execute an op. So op execution, you first you see what op you're actually doing. So look at top op stack and determine the operation. Then pop two numbers from the num stack. Execute the op and then push the result onto the num stack. Pop the top op, you look at it. Is it add? Is it subtract? What is it? Go grab the top two numbers off the num stack and do it. Push the result back onto the num stack. That top operator is gone now. You've done it. Now you have a new top operator, and you look, what's the precedence of that compared to the thing that's coming in? And you decide what to do. And you just keep popping until you get a lower or equal or lower precedence operator.
So we're sorting and executing at the same time.
Ish, yeah.
Or I mean, or you could just be adding it to like a list that you're keeping track of numbers.
I have everything I need right here, these two stacks.
Right. Oh, okay.
Num stack and op stack. So let's look at this picture that I keep talking about from Gishard. Here. Let me close this guy and make this wide. And let's scroll down and see. So here's some stuff about infix and postfix. Let's talk about the conversion here. Okay, here we go. All right, so we start with this infix expression at the top. 1 plus 2 times 3 minus 4 plus 5 slash 6 slash parentheses 7 plus 8. All right, let's see how this is going to go. We find a 1, we push it onto the num stack. We find a plus sign, we push it onto the op stack because there's nothing on the op stack. We find a 2, we push it onto the num stack. We find a star, higher or lower precedence than the top of the op stack. Higher, so we push it. We find a 3, push it onto the num stack. We find a minus sign, higher or lower than star. Lower. So we have to pop star off, and you can see the output there. We pop star off. Now we have minus compared to plus. It looks like equal. We're popping equal. Okay. If you don't pop equal, you're going your precedence, your rules are your ties go from right to left, and if you do pop equal, your ties are going left to right. Okay, so we want ties to go from left to right. Does everybody know what I'm talking about? Ties go left to right. So if the operator's already on the op stack, that means we already encountered it, which means it was to the left of this tied operator, which means it has to happen first, left to right. So what I wrote in my notes, modify that. I want to pop until I get an operator of lower precedence, strictly lower. That gives me left to right ties. Okay, so we get to the minus sign, and that has equal precedence to plus, but plus happened earlier, and so it has to get executed first, so plus gets popped, and then we get to push minus, because there's nothing on the stack, and anything pushes onto an empty stack. Then we hit the 4, put it onto the num stack, or the output stack, whatever you want to call it. Then we hit the plus sign. The plus sign's going to pop the minus, right? Because they're equal precedence, left to right. And I'll just let you keep reading. Well, actually, no. Let's get to parentheses, because we haven't talked about parentheses. So where are we? We're at the plus sign, which just popped the minus sign. Now we read a 5, we push, we see a slash. The slash is division, that pushes onto plus. Now we hit a left parenthesis. Left parenthesis pushes onto everything because it's like an empty stack in a sense. It's like starting a new stack. It's like starting a new evaluation. So let's just keep that. I'll talk. I promise I'll talk more about that in a minute. So we're at the left parenthesis. Looks like left 7 plus 8 down there. That goes onto the stack, but it's invisible. We're just going to leave that alone. Then we get to the 7, which goes onto the stack. The plus sign, which goes onto the stack. Why does that go onto the stack?
Parentheses.
And I think if I had it to do over again, in fact, I might mention this to David, I would probably put the parenthesis in here. Okay, so pretend there's a parenthesis right there. In fact, I can put one in there. Where did I want to put it? Right. Okay. Now, the plus sign pushes onto the parenthesis. We get the 8 and the right parenthesis. The right parenthesis won't push onto the plus sign. In fact, right parentheses are going to pop operators until they hit left parentheses. So right has, in a sense, ultimate high precedence. The only thing that beats a right is a left. And then it doesn't really, even the left doesn't beat it, they just annihilate each other. When you have a right and you're trying to push it onto a left, the rule is just to throw them both away.
And within those, you obey the otherwise rules of operators.
Yes. And then you're done. The right parenthesis comes along and it pops the plus sign, and then it annihilates with the left parenthesis, and then you just push what you have left. You just deal with what you have left. Okay. There's some weirdness here, right? What we want to do is we only want to push onto the stack when the top guy has a lower precedence than the thing I'm trying to push. So a left parenthesis is actually going to have ultimate high precedence when it's going onto the stack, but then it's weird. Once it gets onto the stack, it has ultimate low precedence because everything will push on top of it. So there's weirdness with parentheses, unlike other operators where their precedence relationships to each other are all symmetric. Parentheses are weird. A parenthesis has high precedence when it's coming in, and then low precedence for anything that follows. So there's an asymmetry there. There's a really clever solution for dealing with this problem of asymmetry in precedence. You could, for example, if you weren't thinking about parentheses, you could just, for example, assign integer values to each operator, right? We could say the plus and the minus have 0 precedence. The multiplication and division have 1 precedence. And then you could just do a simple integer comparison to decide, right? Here I have a multiplication operator, here there's a plus operator sitting on the stack. 1 is bigger than 0, push. Or you flip it around, I have a plus operator coming in, that's a 0. I have a star sitting on the stack, that's a 1. 0 is less than 1, so I pop the star operator. But that simple method isn't going to work with a parenthesis because I want it to behave one way when it's coming in and another way when it's on the stack. Ideas? Oops.
Can you run a check to see if something is already on the stack and have a different value if that's true?
Right. That's certainly one possibility.
Can you store a Boolean or something that when you push it in, it just switches the value of that Boolean so you know whether it's in there?
Look at that array and think about it. The left side is an incoming operator. The top is an on-stack operator. And the T's and the F's are answers to the following question. Should I push? Plus incoming plus on stack. Should I push? If plus is already on stack, that means it occurred before the plus you have in your hand, which means the plus on stack goes, which means I don't push. False. Let's go down the first column. Does the subtraction push onto plus? No. Star, does it push onto plus? Yeah, because it has higher precedence. Slash pushes onto plus. Left parenthesis, this is the opening of a new expression in a sense. Does it push onto plus? Yeah. Right parenthesis, don't worry about it. And you just keep reading this whole thing. Okay, look at that left parenthesis row. All true. Look at the left parenthesis column. Also all true. So if I have a left parenthesis in my hand, do I push? Yes. Yes, 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 yes. If there's a left parenthesis on stack, do I push? Yes, 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 yes. Really elegant solution to that problem.
So is the only time we pop an operator when we have another operator in our hands?
Yes. Or you have a right parenthesis coming in and cleaning up the mess. Or you've reached the end of the expression. Okay, so there are a couple, so two additional exceptions. The right parenthesis is going to come in and start executing ops until it does what? Until it reaches a matching left, and then they're both going to go poof, and you're going to continue on your merry way. It's commonly the case that you'll get to the end of an infix expression, and you'll have numbers on the num stack and operators on the op stack, and you've parsed the whole expression. At that point, what do? Just start popping operators and evaluating them until you're done, and you'll have a result at the end. I told you to ignore the right parenthesis line. There isn't even a right parenthesis line on the top row. Why is that? Right parenthesis never makes it onto the stack. Right? Okay. And he's got if you look at the right parenthesis row, he's got a true down there matched with the left parenthesis. I would just sooner put like an X there or something. I mean, you can call it true or whatever, but that's actually a weird special case. If you have a right parenthesis in your hand and you hit a left parenthesis at the top of the stack, you don't do anything. You just throw away the left parenthesis, you throw away the right parenthesis that's in your hand, and move on. So that's a peculiar case. What about starting this whole thing? That's another sort of weird special case. So the first operator that I encounter, I have it in my hand, and I go look at the stack. What's the problem? There's nothing on the stack. So there's another special case. If I have an operator in my hand and an empty stack, what do? Put it on the stack. So an empty stack has ultimate low precedence also. Anything goes onto an empty stack. But that's a special case that you just have to check for. Some people, in fact, Gashard's notes actually suggest that you introduce a super low precedence operator, like a virtual operator, and he uses the $sign, and you just push that onto the stack to start out with. I'm not sure how much I think that's worth it, because it's easy enough to check whether a stack is empty, right? It has a .empty whatever member function, and so just use that, I think.
I don't want to take too long on it, but like, why? I mean, why would you have that operator as opposed to like? Is there any sort of benefit one way or the other for checking empty versus having a low?
I think it's really just whether it's expensive to check for empty.
Okay.
And there is an argument, right? If you push this fake operator onto the stack, then the algorithm just takes care of itself. So it's maybe a sleeker, more efficient algorithm. But in my own implementation, it just seemed like it didn't really matter. It was 6 of one, half dozen the other. In fact, let me show you my implementation. I haven't posted this yet, but it'll be posted Monday. And I just want to show you how mine works. I'm not sure if it's totally bug-free at the moment, but we'll just have a look at it. Okay, 270, homework 3. So here's how mine works, 2 plus 3, say, 2 plus 3 times 2, right? So there we want to hold off on the addition and do the multiplication first, so we should get 8, right? Let's do parentheses, say 2 plus 3 times 2. So now I should get 10 instead of 8 because I have elevated the 2 plus 3 using the parentheses. And these are all the little things that you want to do while you're testing. Make sure that you sort of test these different hard cases. So you can imagine what happened there. I pushed a whole bunch of left parentheses, then I pushed the 2, and I pushed the plus, I pushed the 3, and then I hit a right parenthesis. And it evaluated the 2 plus 3, 5, pushed that back onto the stack. Then I had another left parenthesis sitting on the stack and a right parenthesis in hand, poof, and another left parenthesis and right parenthesis in hand, poof, and they all annihilated each other afterwards, and what was left was one number sitting on the num stack, and that was 5. Jamie?
Could you, like with yours right now, do too many lefts and then too many rights?
I can't remember. No. Oh yeah, I'm going to. I just.
I'll just see what happens when you break the program.
So that I don't think I yeah.
Because too many lefts, I feel like wouldn't be a problem.
Yeah. I actually asked you to do that in your program, so I just haven't done it in mine yet.
So that's not above and beyond. Is another way that you could, as we were talking about checking to see if you're out of operators, could you also just check to see if you only have one number on the stack?
How do you check number?
I mean, if you have one number on the stack and you have an operator left, there's a couple problems with that. I'm going to ask you to implement a unary operator, the negation operator, and so having one number on the stack might still be an operable situation. But there are cases where you have mismatches. You've got more operators than numbers available, and then you can spit out an error message. That's a syntax error of some kind. Yeah, in fact, I think I can pull this up.
Can I see what happens if you just do 2 plus and don't do anything?
So I have some work to do.
What does core dump mean?
It essentially just dumps all the memory and variables and essentially the runtime stack into this big file that you can actually analyze if you have the right software. Okay. There's another one that I want to try. So -3 plus 4. Okay, good. That one works. Yeah, I wrote this piece of code 5 years ago, so, and then I was just looking at it this morning and didn't do much to it. So there's something weird going on here with this minus sign, right? This is a different beast than the regular minus sign, because this minus sign, in fact, this minus sign is not quite.
Is this what calculators have a separate negative sign?
Yeah.
Minus sign? It's a pain in the ass.
Exactly. This is a better demonstration. Well, no, this is not a good demonstration either. Here's a good demonstration.
Plus.
So there, I'm absolutely certain that I used my unary minus operator. The other one, I suspect that I didn't use my unary operator because I go and I peek out here and I see this minus sign and I say, oh, there's a number there. No, I don't do that.
Can you do minus minus?
Yes.
So 2 minus minus 4.
Yeah. So in fact, I was using the unary version up there too, the first one. Yeah, you can do weird things like this, which certain parsers don't do. Okay, and that's successive applications of the unary minus. So yes, I'm quite certain now that I'm implementing unary minus the way that I thought.
If you're doing like 5 plus -2 times 2 plus 1.
That one?
Oh, I guess you could just do 5 minus. Will that, in the general case, be the same? This is interesting. Is that?
Okay. So after I read a plus sign, I go out and I peek and I see that minus sign, and I treat it as a unary minus.
Because you didn't have a number between them?
Yeah.
Okay, so...
Here, let me pull up my description of the homework in the remaining 13 seconds. Like I said, I haven't posted this yet, and it's not something that you really need to be looking at yet, but if you're curious about where we're headed. So number 6. So the hint there describes what I'm doing anyway, is to assume that a dash at the beginning of the input or after a non-right parenthesis operator is a unary negation operator. And that's part of your parser. You've got something that's looking at that incoming stream of characters, and there's lots of peeking going on to figure out how to react to the next thing that's coming in. So we're going to get really comfortable with peek, and that's what we'll start talking about on Monday when I actually give you this assignment. And then problem 11 there is just some suggested above and beyond stuff. You have to, those are all unary operators down there. Well, not the exponentiation, but the others are unary operators. But even unary operators have their precedence, and they have to be filled into the table. And if you have 13 or 14 operators in your parser, then you've got that precedence table at the top, which is going to have 14 rows and 14 columns. Jamie.
Just really quick with the above and beyond, would an acceptable above and beyond be sine, cosine, and tangent, and ln, and x, or are those ors?
I would say 2 of them anyway.
Okay.
Yeah, just to show me that you have the right idea.
Yeah. Okay.
But once you do one of these things, it's pretty addictive.
Oh,
It's,
really?
it's like once you do one, it's pretty easy to just keep going. Yeah.
That is a good point. Sine of cosine.
Okay.
Bare minimum.
So before class today, you had no idea how to parse an infix expression, and now it's obvious, right? Or if not obvious, you can read Gauchard and it'll become obvious. But it's very systematic. Have a good weekend.
Excuse.